This Amateur Logic special presentation of the Voice of America Museum is brought to you by Gigaparts.com, MFJ Enterprises, and ICOM America. At the outbreak of World War II, Axis powers dominated international shortwave radio transmissions. Correcting this deficiency soon became an urgent strategic priority articulated by FDR himself. Robert Sherwood and the Foreign Information Service directed that the first official American broadcast be made in 1941. This initiative ultimately became the Voice of America. RCA, GE, and Westinghouse were called together in Washington to discuss how to respond to this circumstance. Someone mentioned that Crosley Radio had the real smarts both with superpower and shortwave, and they were invited to the meetings. Crosley President James Shouse called Chief Engineer R.J. Rockwell and asked him if he could build a 200 kilowatt shortwave transmitter. Rockwell's response, "I don't know, but I'll sure give it a hell of a try." Crosley Radio, being a smaller, more focused company, was the only one that could meet the challenge without hurting wartime efficiency in other areas. In 24 months, working through war shortages and the few impossibilities involved, Crosley engineers transformed 640 acres of Midwest farmland into the most powerful international shortwave transmitting facility in the world. The technical problems were horrendous. New tubes had to be designed, high-gain rhombic antennas improved, and re-entrant termination advanced to keep antennas from simply melting. It was a time of invention and adventure in the field of radio engineering. The Bethany station originally required 3.5 million watts of electricity to operate. When it became operational, the VOA had the highest priority for electrical service. Cincinnati might be blacked out, but the VOA would still receive electricity. Birds landing on these radio frequency transmission lines had a tendency to explode and simply vanish into very small pieces. The Bethany team designed and built history's only high-efficiency rhombic antenna system. It was the most efficient operation in the VOA system and the most sophisticated antenna system ever devised. This system generated a sharp beam with an effective radiated power toward the target area of nearly 10 million watts. From 1942 to 1944, international shortwave broadcasts took place from the studios and transmitters of WLW in Cincinnati. Tell the truth and let the world decide. Hitler called them the Cincinnati Liars. For 50-plus years, the Bethany station broadcast the truth and brought hope to millions trapped in totalitarian regimes, 7 days a week, 24 hours a day, and in 52 languages at its peak. Well, I'm talking with Dave Snyder here, a former employee of the Voice of America. Dave, you spent many years here, didn't you?
14 years.
14 years. And where are we standing right now? What is this called?
We're in the antenna switching matrix. Any one of our 6 broadcast transmitters could be connected to any of the 22 antennas via the switching matrix. So it's a gigantic telephone switchboard of 300 ohm balanced transmission line, 216 cross points out here for balanced transmission line. We happen to be at the junction of transmitter number 5 and antenna J2, the South America antenna. So the way the lines come in, the lower lines across the antenna switching matrix are the trunk lines from the transmitter. So connecting transmitter number 5 to antenna J2 where we are, this handle has to be in the up position, and connecting antenna J2 to transmitter 5, every switch has to be up until this switch matrix point, and this handle has to be down. So the incoming line north-south makes a twist 90 degrees, connects to an east-west line to go out to the antenna. Just a little bit bigger than your TV twin lead.
Yeah, and how often would somebody have to climb up there and tighten those nuts?
We had annual maintenance on the switch bay. When we shut down, we sent one of our early morning schedules down to Greenville, North Carolina plant, so we'd have about 6 hours off the air, and we would go through and completely clean every switch, would take the actual switch blades off where they were pitted, and would flow brazing rod onto the pits and then refile them so they were flat again. and all the hinge points all got cleaned, lubricated, all the switches got polished. So one big annual maintenance project, but insulators would break all the time.
So did you ever see any big arcs out here?
Well, you never switched an antenna under power. So
that never happened.
Intentionally never happened. Okay. But we had unusual situations, like here at number 5 line, when we were running a frequency schedule on 17,800 kilohertz. That was actually on antenna A1, back a couple. You could go out 5 switch points and open the line switch, and you had a 5-foot arc off into space, which would sit there and talk. This nice blue flame would talk with the modulation, and it was very unusual because it never affected the visuar of the transmitter, but something was resonant in about 5 switches, and open one switch into nothing, this nice blue flame would just go off at about a 45-degree angle. It was impressive to see. I have pictures of it.
Wow. And you were telling me a story a moment ago about one time the station was down one night here, and some local hams came out and y'all did a little experimenting.
We had the Dara group come down and bring their mobile radio vehicle, and we clip leaded on to a lot of the antennas and aimed toward Africa and toward the Middle East, and did some unusual strong contacts over there and did some impressive things. Unfortunately, the band wasn't really wide open that night, but it was a fun night.
Well, I bet it was. I had often wanted to load up into some of the broadcast towers I worked at, but never did. That would have been an excellent antenna site here for a ham radio operation. Is this motorized at all, or was all this hand done?
This is totally manual. So about 6 to 8 times a day, someone would have to walk the 300 feet from the building out here, would say over the intercom when the transmitter was off, and they would set up the antenna switching for the next schedule. 365 days a year, snow, rain, sleet, tornadoes, skunks, many skunks. Actually stepping on a skunk 3 feet from the transmitter building door. Yes, and a very fast exit from that. Someone had to come out here and operate the switches.
So skunks are attracted to high RF energy, huh?
No, skunks are attracted to the yard lights out here. The June bugs would all bump into the yard lights, knock themselves silly, fall down to the ground, and the skunks would have a feast all night long eating the June bugs that knocked themselves out on the light. So it's fun to come out in the summertime and watch the skunks eating the June bugs.
So I notice, there's a lot of wood construction here, and there's wood here that's actually used as an insulator to go up to the actual switch itself, and the copper's kind of turned green. When was this built?
This was built 1944. So this is original. This is our last remaining portion of 1944. The shell of the building and the antenna switching matrix are the last part of the real ancient history of the building.
So VOA went on the air from this site in 44. When did this site get decommissioned?
Our last broadcast was in November of 1994. So we made the 50 years.
So this building is a museum now. We'll go inside and look at that in a moment. When did the restoration begin here?
Well, we began restoration shortly after it shut down. One thing that happened was the building was built in the winter of 1943 and 44, and it was built during the coldest part of the year. So some of the actual mortar joints were compromised because they didn't have the admixes back during World War II that they have nowadays. You can work much colder temperatures with the concrete. And when the building was shut, when the transmitters were shut down, there was no longer any heat in the building. Each one of our broadcast transmitters made almost 1 million BTU of waste heat. That waste heat we pumped into the ductwork to feed all the various parts of the building. And if we had one transmitter on, we were toasty. We had heat any place in the building. Well, when the transmitters were shut down, suddenly no heat except a few space heaters, and the building began to deteriorate. So we had a project, actually a State of Ohio project, restored the exterior brick, the glazed brick, which you see on the front of the building, the wraparound. That was all paid for by a state grant, and that is all new. And then we've also had a new roof put on since we shut down, and we also have insulation, because a transmitter plant, as you can imagine, each one of the transmitters, we took in about 23,000 cubic feet per minute of cooling air just to cool the transmitter area, not excluding the heat exchanger. Just 23,000 cubic feet per minute of cooling air just dumped into the building. All those exhaust outlets were great for all the winter heat to escape right out through the roof. We couldn't heat the building, so we've also had a roof project to close up the majority of those openings. So we have one heat exchanger left for number 6 transmitter. That'll be a museum piece. Otherwise, the roof is pretty well closed up.
So when, the antennas aren't here anymore, I understand they were taken down, I guess, due to getting old and just not being used anymore. When was that?
The antennas came down in 95 and 96, and the majority of the land, more than 500 of the 600 acres, was conveyed to parks. Well, if it's going to parkland, you can't have antenna towers, because that's a liability. Some kid is going to want to climb a tower. No matter what you do in fencing off a tower, somebody's going to want to climb it. Look, Ma, I'm up 200 feet. And so it's a great liability, so they all had to come down.
We'll be back with more of our special presentation of the Voice of America Museum in a moment.
Built to last, the ICOM 7410 is the only rig in its class rated for 100% duty cycle, making it the best choice for RTTY, contesting, and digital modes. Get more performance for your money with its best-in-class dual conversion receiver, greatly reducing internal phase noise insertion points. The 7410's large LCD screen makes it easy to operate its more advanced features, and the USB port makes it simple to connect to your PC for rig control, logging, or digital modes. No other radio in its class can deliver the performance or reliability offered by the ICOM IC7410. Gigaparts is the largest independent amateur radio dealer in the nation. Everything you need for ham radio, including books, DVDs, antennas, rope, coax, and tuners. Gigaparts has it all and is open Monday through Saturday. Call us toll-free at 866-535-4442, and our friendly staff will be happy to help you find the right products for nearly any project and budget. Online shopping made easy with real-time pricing and availability, and free shipping on most orders. Go to gigaparts.com and enter to win a free radio. Have a question? Click on Live Chat for a quick answer. Low prices? Huge selection. America's favorite ham radio store is Gigaparts.
Right behind me, you can see the dummy load building. We did have a phantom antenna, which was capable of our 250 kilowatts fully modulated, plus a few extra kilowatts of dissipation. So we could test a transmitter under full power at any time of the day or night. It was a luxury to be able to do some work on repairing a transmitter and then bring it up on full power and test it without interfering to half the world.
Yeah, I bet. So how did you get the power out here from the transmitters out to the switching network?
From the transmitters themselves, they ran through ducted line inside the building, made a transition to open wire. So 300 ohm balance line feeders out to the switching structure. The curtain antennas were 300 ohm antennas. So it remained 300 ohms all the way out to the 8 curtain antennas. For all the 14 rhombic antennas, they were 560 ohm lines. So there were quarter wave step transformers right adjacent to the switching structure. So there was 2 more lines of poles right on either side of the switching structure lined up north-south, and those contained all the matching transformers, or the step transformers.
How big was the wire on that open 300 ohm line there?
Basically, they were 2-aught. The 300 ohm lines were 2 lines parallel, about 12 inches apart. The 560 ohm lines were 2 1-aught cables about 14 inches apart, spaced vertically, or the wires ran vertically.
I see you've got some pictures here of what appear to be German radios. What's the story on that?
Well, the Volksempfänger is a very important piece of our story. So in 1931, Hitler's Minister of Communications, Goebbels, decided that this tool of radio was going to be very important to the Third Reich. If you got the people's ears, you got the people's minds. And the old theory that if you told a lie enough times, eventually somebody's going to believe you. So they decided to make a subsidized radio receiver called the People's Receiver, and the People's Receiver could be distributed to the German public for about 1/3 to 1/4 of the cost of an average radio receiver. So 1931, they made the first People's Receiver, and this is the 1931 model. This is more of a mid-30s model, and this is the last model, the 1939 model. It only had long wave and medium wave. It did not have a short wave band, and it only had 3 tubes. It was not a sensitive receiver. It was made for listening to local stations. And of course, Hitler, by World War II, by Pearl Harbor Day, had 68 radio transmitters on his network under his control. And if you go back to the People's Receiver, by 1938, every other German household had the People's Receiver. There were 8 million of them in Germany, and by 1943, there were 15 million People's Receivers across Europe. This is the reason for the Voice of America, because Hitler had this tremendous propaganda machine where he had the people's ears. They couldn't listen to radio stations from the West. They couldn't listen to the BBC from London. They couldn't listen to the U.S., any of the Voice of America stations, or at that time the Office of War Information stations, because they didn't have abundance of shortwave receivers. So someone who had a shortwave receiver had to actually listen clandestinely, hear what was being said on the Voice of America. One person told 10 people told 100, and the next day after something was announced on the Voice of America, many hundreds of people knew it even though they hadn't heard it. So the underground, the whispering of messages, radio was so important, so strategic during World War II. We're standing in the 1965, the Modernization Control Room. So we call this our NASA-looking control room. Across the front we have our audio switching control. So the whole audio matrix switch was controlled by that board there, the old preset and master take. So if you had 10 changes to do on the hour, you could set up all the preset, the switching on the presets, and just push one button and 10 things would happen. Actually had 12 audio inputs plus a test tone. Could go to each one of the 6 broadcast transmitters and the 2 independent sideband transmitters. So Bethany 1 through Bethany 6, and switching, selecting a source and then selecting an on or an off switch.
Mm-hmm. So what were the 12 audio sources? I know you told me you didn't really originate programming in this building. All the programming came out of Washington. How did it get here?
Up until 1985, all of the programming got here from Washington and from Armed Forces Radio Studios in Los Angeles via telephone lines. AT&T long lines, the regular broadcast circuits, which distributed all the radio and TV networks around the country, gave broadcast loops. And so we had just regular old normal broadcast loops coming in from Washington. In 1985, AT&T said we're no longer going to provide broadcast service. And so that's when we installed the satellite system. So the KU dish, which you saw on the east side of the building, That brought in actually 12 audio channels from Washington, D.C. We had numerous different sources we could broadcast from. And then on the west side of the building, we had a TVRO dish, which also had VOA programs on subcarriers. So if the KU, something would happen to that, we still had the C-band, which had most of our programming on it. So we were well equipped for getting programs here from Washington. On the other side, we have transmitter number 9 and transmitter number 10, and those were the two independent sideband transmitters. And of course, they could carry two programs simultaneously, one on upper sideband, one on lower sideband. And in doing so, at 50 kilowatts PEP, there's almost as much power in 50 kilowatts PEP as in the sideband power of a 250 kilowatt broadcast transmitter. The 50 kilowatt PEP transmitters were on point-to-point frequencies, not in the broadcast bands, but on point-to-point frequencies. So Washington could send a program via the satellite, via the phone line to Bethany. It would come through Bethany, be out on a HF frequency, come down in Monrovia, Liberia, and Kavala, Greece, Wolferton, England, and they would use that for a program source or a backup program source. So there were times where we would have a burp on a transmitter and we would hear from England, your transmitter dropped out, we heard it.
Now, what is this panel on the end over here? I say it says something about antenna selection, but your antenna switches out here were manual.
When they started a modernization project to give Bethany remote control antenna switching, they got part of the project done. They installed the controls, so we have these nice-looking readouts and nice-looking push buttons, but unfortunately they don't do anything. So we maintained the manual antenna switching to the very end, and one of our guys here figured out a project to go out there and actually put reed switches in. So you saw those little round things on the end of the manual switches. Those are magnets and reed switches in there which detect whether the handle is up or down and what it does in the matrix, and actually sends the DC signal back in here to light up the lights. So we had antenna readouts. We knew that the antenna was made to the transmitter simply because of that, but manually switched.
We'll be back with more of our special presentation of the Voice of America Museum in a moment. Digital signal processing, or DSP technology, is a topic HF operators have heard for many years, but DSP is all the same, right? Not exactly. ICOM is the leader in IF-DSP-based HF transceivers. From the first analog PLL circuit in the IC200 to the IC756 Pro, which used groundbreaking 32-bit DSP technology, ICOM is a true pioneer in the amateur radio world. ICOM's DSP technology starts in 1995 with the IC775 DSP, a hybrid radio with an almost cult-like following. Now fast forward to ICOM's current HF product line. With the exception of the IC718, all ICOM HF radios benefit from the design surrounding IF-DSP. So what's the difference between AF and IF-DSP? AF-DSP occurs after the product detector in the signal detector. The target signal is probably masked by man-made or environmental interference. IF-DSP reduces or eliminates interference and the masking effects caused by strong interfering signals over weaker signals. IF-DSP allows automatic gain control to focus on the weaker target signals. Although there are variations between models incorporating IF-DSP, the current IF-DSP HF radios from ICOM have the following basic tools: AGC loop management, build your own IF filters, twin passband tuning with filter width and shift, automatic notch filter, manual notch filter with selectable wide, medium, and narrow, noise reduction, noise blanker, and RF speech compression. More advanced features are available on the IC7600, the IC7700, and the IC7800. Microphone EQ, receive audio EQ, dedicated 32-bit DSP for real-time band scope, and for the 7700 and the 7800 bigger rigs, auto peak filter for CW. Make sure you visit ICOMAmerica.com for more info on powerful IF DSP HF radios.
You see two major catenaries between each one of the tall towers. One side holds a reflector screen. So all that happens off of this catenary is a reflector screen. And off of this catenary are all the dipoles. So each one of these antennas, 4 antennas between each of the big towers, they were 2 by 4 curtains, 4 dipoles high by 2 dipoles wide. So what we call a 4 by 2 curtain. There were curtain antennas much larger in the world, curtain antennas much smaller, but ours were 4 by 2, which gives roughly 21, 22 dB gain. The 4 antennas were different sizes. So on the end here we have antenna T1. That was good for 9 and 11 megahertz. Those were the longest, the largest dipoles. They were the highest off the ground. The next antenna was T4, which was good for 21 and 17, or 21 and 19 megahertz. And so it was a much smaller antenna. And when you were out there looking at it, you could see those dipoles were much shorter, much lower to the ground, and the reflector screen was actually pulled closer to the antenna. So pretty much you could see 4 different sizes. Very difficult to get a picture of it, which really represents. And then this was, again, exactly opposite, duplicated. So the S group on the north side, you had S3, S2, S1, and S4. So each one of the curtain antennas could be tuned with capacitors to 2 broadcast bands, 911, 1115, 1517, and 1721.
A lot of hams are going to recognize this name right here, Collins. What is this?
We have great respect for Collins Radio because they work. We have 3 remote controls lined up here for number 4, number 5, and number 6 transmitter. And of course the remote controls have readings or meters on them so we can tell plate volts, plate current, and power output. But better than that, these were actually remote controls for the transmitter. Whenever we tuned the transmitter, we had an operator directly in front, so you can watch you can hear all the relay stuff, you can hear the servo motors run. You can tell just by the sound that the transmitter's tuning properly when it switches from coarse tune to fine tune and so on. But if you had nobody available, you could actually do a frequency change from inside the control room. With the thumb wheel switches, you could dial up a new frequency, select a new crystal, and at the appropriate time from either the control board or from over here, hit the tune start button. The transmitter would remotely tune itself up out there.
Yeah, because these transmitters weren't like a typical broadcast transmitter where they would just sit on one frequency all the time. Y'all change frequencies throughout the day on these transmitters. That meant, I don't know what it meant, changing inductors, maybe some capacitors, maybe some relay switching, just any tuned circuit in there is pretty much going to have to be readjusted for each frequency, right?
These transmitters were rather unique. They had for the driver input and the driver plate, they had a spiral coil, which actually changed the capacitor while it ran the roller on the spiral coil, tuned by a servo motor. But the output tuning network, the thing that matches plate impedance to line impedance, was actually all tuned with capacitors down a pi line. So there's 1 plate tuning capacitor and 5 additional tuning stations, depending on the frequency, determine which tuning station would actually be the loading capacitor. So the actual physical distance between the plate capacitor and the loading station was the inductance, and the output was like 70 ohms unbalanced into a tune balun, which then converted the 70 ohms unbalanced to a 300 ohm balanced line. So 26 water-cooled vacuum variable capacitors in each one of the transmitters. A very unique design. Collins only ever built 9 of them. 3 of them were here, 3 of them were at Dixon Relay Station, 3 of them were at Delano Relay Station. So this is the 821A1 model. Then Collins built an 821A2 model, which went to Radio Canada. So Sackville had the next latest model of this transmitter, and they switched from all those vacuum variable water-cooled capacitors back to a sliding hairpin for the output network.
I'm taking it, this is Bethany number 6 transmitter?
This is number 6 transmitter. This is just the front control panel of it. This is the diagnostic and metering panel. And basically, All of the 9 servo amplifiers are in this cabinet, which run all the tuning. The driver amplifier is in here, and right directly behind the driver amplifier is the power amplifier. Consists of 2 tubes in parallel, 4CV100,000C tetrodes, and those are vapor cooled. So the anode of the tube sits in a water bucket. When the water reaches 100 degrees C, it can't get any hotter. It changes phase, changes to water vapor, i.e. steam, goes up through the big 4-inch copper tubing there up to a steam condenser. The steam condenser is nice and cold because it's got cooling air blowing through it, so it's very attractive to hot water vapor. Condenses back to liquid, trickles back down in the system. The whole cooling system for the power tubes and for the 2 modulator tubes farther back on the wall is all done by gravity. When the transmitter is operating during normal modulation, 2.2 gallons per minute is condensed. That equals 1 million BTU of waste heat. That waste heat was pumped into all the ductwork, which fed all the corners of the building. So the building was heated in the wintertime by waste heat from the transmitters. Talk about a green building. We had a green building in 1944.
Probably one of the earliest. So this transmitter could put out how much power?
This was 250,000 watts. So when you looked at it, 14.25 kilovolts on the anode of the tube, which was 13.5 kilovolts from anode to grounded grid, and minus 750 volts on the cathode, and 22 to 23 amps was sure to give you 250 kilowatts out.
That's a lot of amps at that much voltage.
Yes. We boiled a lot of water too.
What vintage is this transmitter? Do you know approximate date range of it?
These transmitters were basically developed in 1960, and these happened to be installed around 1965. Plate tuning capacitor is labeled C1 here, and then C2 through C5 are the loading stations. C6 is way down the line, and it's the loading station right up here on the top of the transmitter. And then we have a tuned balun, which also is a harmonic filter. So 26 water-cooled vacuum variable capacitors, all tuned by servo motors and all tuned in roughly 10 seconds.
That's pretty fast. What is this box up here above the transmitter?
That is the pi line, what we call the pi line. So capacitor C1 tuning capacitor is way down here on the ground right behind the PA tubes, and that is the last loading station on the top. That is C6, the last of the 5 loading stations, and that loading station is 5.5 to about 7 megahertz. And then right immediately to the left of that is the input to the balun. The balun is approximately 70 ohms in and then 300 ohms out. And the balun is very distinctively a harmonic filter, so it really does discriminate against harmonics.
So is this sort of like a coaxial transmission line here?
It is a coaxial transmission line with a 24-inch square outer conductor and a 10-inch aluminum pipe as an inner conductor. And it just so happens there's a copper tube which runs all the way down through that, which carries the B+ from the power vault to the PA tube.
We'll be back with more of our special presentation of the Voice of America Museum in a moment. In 1972, MFJ Enterprises Incorporated was founded by Martin F. Jew in a small rented hotel room in downtown Starkville, Mississippi. The first product was a highly selective filter which enabled a receiver to separate one Morse code signal from scores of others. Several thousand units were sold, and that was the seed that grew into the MFJ of today. MFJ products are almost as diverse as its people. MFJ Enterprises is well represented worldwide with over 200 dealers in the United States, 40 overseas, and 10 in Canada. Extensive research and development goes into each of the new products constantly on the horizon as MFJ continues to create and innovate. MFJ's sister company, Ameritron, is the world's high-power leaders. No one has a wider range of HF amateur radio amplifiers. From Ameritron's AL811, the world's most popular HF amp, to the legal limit giants and the new solid-state models, all Ameritron amplifiers are constructed, tested, and serviced in their own Starkville factory. In the year 2000, Hy-Gain joined the MFJ family, bringing rotators and antennas used worldwide. The Tail Twister is the most popular rotator in the Hy-Gain product line. It's become the standard by which all others are measured, and Hy-Gain offers a wide variety of antenna products designed for maximum performance. The newest family member is Cushcraft, a long-respected company which offers peak performance beams, verticals, Ringos, and Yagis. Not only does Cushcraft build a wide variety of HF antennas, but also VHF and UHF antennas, including the legendary Ringo Ranger and Yagis. To round out the organization, Mirage Amplifiers was added in 1995, bringing the world's most rugged VHF-UHF amplifiers. And just for fun, Vectronics has kits for the joy of building and play. So you can see why MFJ is the world leaders in ham radio accessories. Visit mfjenterprises.com today.
The World War II Crosley homemade transmitters started out with an 807 tube, and everybody knows the 807. Went to a pair of push-pull 813s, and then the 1194, the little water-cooled tube with 7.5 kilowatt plate dissipation. That is the RF driver tube. The one next to it is the audio driver tube, and then the big tube out here is the RF output tube. And we used two tubes that looked exactly alike. One had a little bit different mu, so a little bit lower mu tube for the modulator than the power amplifier. And then in a picture there we have a picture of Jack Gray, who was one of Crosley's chief engineers. And Jack Gray is the one who the Jack Gray History of Wireless Museum is named after.
So how many of these tubes here would there be in the final section?
2 of them in push-pull.
And I guess the same thing in the modulator.
In the modulator, there were 4 of them in push-pull parallel.
I've seen plenty of 4CX 15,000s, but I think this is the first 4CX 100,000 I've ever seen.
Well, we actually have 3 examples of the same tube here. The one on the very left is a 4CX 35,000C, and that was used in many, many 50 kilowatt transmitters around the country. The one in the middle is the 4CV 100,000 as originally supplied by IMAC, who was the builder. And then the tube on the right is a 4CV 100,000C, which has been rebuilt by Econco. And you notice that the fins are completely different. They came up with a much wider fin, and there are slots in the fins, and actually horizontal slots in the fins, which all promote better boiling. So much better heat conduction from the anode out into the water to promote better boiling. There were some original problems with the soldering on the IMAC tubes where there was actual loss of contact. So the Econco rebuilt tube was much better at dissipating the extra watts.
Yeah, that's something a lot of hams may not be aware of, but on these larger broadcast tubes, they're pretty expensive. So there's a company, Econco, there was another one named Freeland, that you could send your dud tubes to, and they would rebuild them. They would change out the elements on the inside, and this is the first time I've seen one where they really made major modifications to the tube. But that was an IMAC when it began life, and then rebuilt by Econco in this new fashion.
Right. And there are also a lot of other changes. Basically, the grid structures remain the same. You never need to touch the grid structures, but you do get a whole new filament when you rebuild a tube, because the original filament is what has worn out. It's lost emission. The thorium has boiled off or whatever. Maybe you've got open strands. You have no longer really good emission, so that makes a dud tube. So you get a brand new filament, and all kinds of technology go into that filament, the percentage of carburization, whether it's thoriated or not, the temperature that it runs. There are many, many deep sciences in building a filament for a power tube.
Yeah, and most hams don't consider it, but in broadcasting, the tubes are so expensive, you want to get as much life out of them as you can. So I know on AM and FM, we were real particular on keeping our filament voltage right where it needed to be. We had regulated supplies and all. Were y'all constantly on top of filament voltage here?
The tube is actually designed for 11 volts on the filament, and we ran 10 volts. We did a monthly test where we would actually drop the filament voltage, and we would measure distortion as a factor in the emission of the tube at reduced voltage. And so it was a monthly thing where we actually did a test. And then the more modern transmitters actually run black heat. So the tube is never totally shut off. Even in a completely shut down transmitter function, you actually have a couple volts on the filament, which keeps it warm. And so the original turn on the inrush of current, which will actually commutate the strands in the filament. They want to vibrate when that current rushes in. That's all reduced, and your tubes last considerably longer if you can use black heat function.
Welcome to 30 minutes of VOA Special English, a way to learn American English and much more.
Years ago, VOA's emphasis was on English. And so for each one of the 4 English language networks, they did an hour of special English, plus a newscast in special English. Special English is read at 1/3 slower speed and only uses 1,500 word vocabulary. And so I always wanted a special English dictionary. Well, I have one here, and this is those 1,500 words translated. Well, not translated, but a definition. It's a dictionary. And so if you leaf through here, there's diagrams, pictures, and at least a full line of explanation of each one of the words in the dictionary. And these were also translated into other languages. So if you were trying to learn English, then you could get one of these at the embassy, at the consulate, at the USI library, bring home a special English dictionary, listen to VOA, and if there was a word that you just couldn't understand at all, you would grab your dictionary, look it up, and you'd still get the meaning of that sentence as it was being read over the air. So many, many people learned English by listening to the Voice of America.
Oh, wow, didn't know that. So this is the Voice of America amateur radio station here. Is that a special club, or is this part of DARA, or what is it?
No, it's the Westchester Amateur Radio Association. It's a unique club here at the Voice of America. And our purpose is to support the museum and have a world-class operating station.
Are you a former Voice of America employee yourself?
No, I'm not. I originated in Iowa and ended up here in Cincinnati many years ago. Okay. So I was here when this operation was going, but never got to tour it.
Wow, that's a shame, because it probably would have been really something to see in its day.
Oh, it must have been. I've been by the antenna field, but was never really in the station when it was going. But it was quite an operation from what everyone tells us. We have several members who are employees here, and they can tell you some very interesting stories about it.
I bet they can. So how often does this station operate?
Well, we operate now on a regular basis every week during our meetings, and we have an operating night. The station was shut down for a few years while they were renovating the building. So it's just been about the last 2 months that we've been able to get it back in operation now. And we're setting up a regular contest schedule, and we do some of the other events like a Jamboree on the air, and some of the other special things, but that's primarily what we want to do, as well as offer some ham courses.
And here's Dave Wickelhaus, the president here of the Westchester Amateur Radio Association. Did I say that right, Dave?
Yes, you did, George. Yes, you did.
And this is another one of the stations at VOA.
Yes, it is. We now have 2 stations. As I think Bob mentioned earlier, we've been off the air for almost 3 years, and just recently got one operating station back on, and now we've got this other station with the 746, which was actually our original radio, along with the nice microphones that Bob donated to us for the VOA.
And you've got some vintage gear up here on top, too. Does that stuff still work, or is it just I hope it's going to work one day?
Some of this is actually functional radios. It's one of our plans is the area out in front here with the big glass window will be a display area where we will actually be operating vintage amateur radio equipment that we'll be cycling out of the Gray Museum.
All right, thanks, Dave. Maybe we will catch you on the air, too, when we catch Bob.
Oh, absolutely, George, absolutely. We will absolutely be on the air with the WC8 VOA call.
ባለፈው ሰሞን በጎንደርና በወሎ መካከል የሚገኘው የዋልድባ ገዳም ይዞታ ለልማት ሊውልና በተለይም የስኳር ፋብሪካ